Hey guys, in this video we're going to begin chapter 4, motion of fluid particles and streams. So the content of this chapter include the types of flow, which is what we're going to cover in this video, and then the second part, which is equations that you can use to measure the movement of fluid. Alright, so there'll be 2 more videos coming after this one. So a flow can be classified into different categories. Okay, and what I'm going to share in this video is not all of it, but it's the most common categories. So the first one is uniform flow and steady flow. Okay, uniform flow is when the properties or the velocity are more commonly studied in a flow at any point is the same. So it depends on the region that you're studying. So if you're studying a 1 meter length pipe, then the velocity in that pipe is the same at all points. Okay, that is uniform. And steady flow is when you have constant properties in the flow with respect to time. So when you have steady, remember it's always related to time, and uniform is always related to location in the region of study. So from these 2 categories, we can develop 4 types of flow. Okay, steady and uniform. We can have unsteady and uniform, steady but not uniform, and unsteady and non-uniform. Okay, so the steady or unsteady flow will depend on the reference frame. So if you remember, I'm sure you've been given an example of relative velocity, where if you're standing on a moving train, the velocity of the train, according to you, if you're the observer, will be 0 because you are both moving at the same speed. So the same thing applies here. Okay, whether or not a flow is steady or unsteady is depending on what is the reference frame. Okay, from which point are you observing the flow? Okay, the second classification is real fluid versus ideal fluid. So bear in mind that all fluids are real fluids. In the real world, everything is real, right? But sometimes assumptions can be made to idealize these real fluids. Okay, idealize means make them easier to analyze. Okay, a common example is the compressibility of liquid. Just take water for example. We know that water can be compressed, it can be expanded. Alright, but in common cases, okay, in common applications, water behaves like liquid water. Okay, so in that case, it is considered as incompressible. Okay, so this incompressibility is the idealization. Okay, it's not actually true, but it is true in that specific case. Okay, next common thing that is idealized is the viscosity of the liquid. So all liquids will have viscosity. Okay, if you remember, viscosity is the ability to move. In chapter 1 we discussed this. So in ideal fluids, we assume that it has 0 viscosity, therefore it does not have any effects from the viscosity of the fluid. So viscosity of the fluid will cause shear, okay, will cause shear effects, which you learn more about in chapter 8 and 9. Okay, so an example of this you can see in this diagram. You have flow moving through this let's say circular pipe, and from the side this is the flow. This line, this blue line and these arrows are representing the velocity of the flow. So in an ideal fluid where it has no viscosity, the velocity will be constant from the top to the bottom. Alright, but in actual case, in the real fluid, this is the velocity profile. This means that the velocity is high at this area. See the longer arrows or the vectors, and it is reducing and reaches 0 at the wall of the pipe. Okay, this is the real case. but in an idealized fluid, we always take this as an example. Okay, another classification is 1, 2, and 3D flow. So one dimension flow, an example of that will be the pipe flow. This is the same example that we saw in the previous slide. So why this is called one dimension flow? Because the properties are only changing in one direction. Properties here specifically is the velocity. Okay, the velocity is only changing in the horizontal direction. You don't have flow going upwards. So that's a 1D flow. A two-dimension flow is where the velocity is changing in two directions. So it's changing horizontally, but it could also change vertically. So you see this flow can go up and down. Okay, can move in a circular form like this. So of course a 3D flow is a flow where the velocity changes in all dimensions. So some questions to ask when you want to make the assumption of 1, 2 or 3D flow is, does property vary in the flow direction? Does property vary in the other two dimensions? So if it varies only in one dimension, like in this case, then it's a 1D flow. Otherwise it's 2D or 3D. Okay, so this is the classification that we have, the major classifications, and I'll see you in the next video.